All right, welcome back everybody. This is the developing section of 2.7, so hopefully you're in the right video. So let's talk a little bit about what is in this section. So you'll notice if you're looking at your notes that you have a table. Clean this table up just a little bit. You have a table that now is talking about an irrational number, okay? So in your section of what I can do, it says I can label and categorize numbers, all right? But I wanted to explain a little bit about these numbers. So we talked a little bit about rational numbers, integers, and whole numbers in 2.1. So that's why this part is here. And with the square roots, sometimes you get numbers that don't exactly fall into those categories, okay? Now I'm going to add two more categories on for you here. There's real numbers, okay, and irrational numbers, all right? Now this table over here, I'm going to move this camera just a little bit. This table over here is a great representation of how this works, okay? So real numbers cover everything that we're going to have in our categorization of this, okay? So real numbers cover everything, okay? Now, irrational numbers are going to be over here, and I'll explain what these are here in a minute. I just want to give you a visual of what you're looking at when you're kind of looking at the practice problems and those types of things. So irrational numbers, and then you have the ones that we did in 2.1 where they kind of overlapped, okay? So if it was a whole number, then integer, and so on and so forth. That table that we did for 2.1 is kind of right there. You'll notice that this one and this one do not overlap. So if it's one of these, it will not fall into these categories. Okay, so moving the camera back over here, let's talk about this table. We understand that rational numbers, okay, they're decimals and fractions, but these decimals are different than irrational numbers, okay? Rational numbers, if you look back at our notes, they stop, okay? They stop, they end, maybe it goes 6, maybe it goes 10 spots past the decimal point, but they do stop. Or they repeat, all right? They repeat, they go, like my example up here, so 5.333, and the little bar above it means that it just repeats forever, okay? An irrational number is a little different. This one does not repeat, okay? There's a very famous one that's actually right here, okay? This would be an irrational number. Now, if you don't know what that symbol is, that's pi, all right? So 3.14 whatever, and it keeps on going forever, and I believe there's computers that are still trying to figure it out, and I don't know if they ever will. Probably not. So I made this one up, so this number would be kind of what you would see as an irrational number. It just keeps going. It never repeats, doesn't recycle the numbers in there. Even if it was just like 314 and then it said 314, that's a repeating section. So let's go ahead and categorize these numbers here that I have. You'll notice that each of these are under a square root symbol, okay? We gotta get used to the idea that there's more than just the easy numbers out there, but these are fairly simple, these ones right here, so we'll make that work, okay? All right, so the square root of 24, once again, please have a calculator. Once again, if you haven't got one, you need to get one, okay? Now, for my ability to read this here, it goes, if you did the square root symbol in here, 4.89897948.6. Notice it doesn't say repeating, doesn't say, so that means that the number stopped, okay? So the number stopped. According to what I just said, if it stops or repeats, then it's up on the top up there. And it would be a rational number. Now these are not in order, the labels, so it's partially to try to trip you up just a little bit to get you to understand that you know. Anyway, so I told you that rational numbers, okay, rational numbers, looking at this little table here, fall under real numbers. Okay. And that rational numbers do not overlap with irrational numbers. So it is not an irrational number. We know that integers, okay, looking back at this thing here, integers don't have decimals. Okay, there's no fractions, no decimals, so not that one. And whole numbers are just 0, 1, 2, 3, 4. So no in that one as well. Okay, so try the square root of 100. It's a fairly simple one. Hopefully you don't need your calculator, but we'll find out. So what times what makes 100? It's 10. So 10 is your answer there. So everything falls into a real number. Okay. 10 also falls into a whole number. I'm going to go backwards just a little bit. Whole number, and integers are positive, negative, and 0 with no decimal, so it also falls into an integer. Irrational number, so it's starting to fall into these categories here, so that would mean that it is not an irrational number. Okay, so let's talk a little bit about the rational part. It fell into whole, integer, and so that would also mean that it was a rational number. Now, in one of my videos, I think if I haven't fixed it, I'm probably going to, was that I said everything's an integer. Well, that was actually wrong. I pointed to the right spot, but it was wrong. Everything, for the most part, that we were doing in section 2.1 was rational numbers. Okay. So that same clue actually goes for this one. Probably everything we do is going to fall into a real number. Okay. So if you're doing this section and you get this table on one of my quizzes and you're like, oh, well, I'm just going to, everything's a real number. Okay. I would like you to learn what it is though, so that's fine. So negative square root of 81. All right. So if you think about it, what is the square root of 81, first of all? Well, square root of 81. What times what? 9. Okay. So the negative sign goes back onto the front, just like we learned in merging section. So it's a negative 9. Is it a rational number? Yes. Irrational number? No, because they fall into the two different categories. Integer, negative 9. Yes. Whole number? No. Okay. That's because whole numbers, once again, 1, 2, well, it's 0, 1, 2, 3, 4. So they're all positive numbers and 0. Now, here we go. This is pi, all right? This little guy here is pi. Now, when you get into things like geometry, he's going to be really important for you, okay? And some of the trigonometry and that type of stuff. So you'll see him around. He'll be around a lot. Now, we said that pi is a real number, because everything's a real number at this point, that you're going to be working with. Now, you have rational or irrational. Now, we said that pi was like this number here. It's never been stopped. It never repeats. So that would be a irrational number. And if it's a irrational number, it cannot be a rational number, which means it cannot be those two either. Okay. So there's your table. Hopefully that makes sense. Hopefully you're able to do it. Once again, being online, I can't ask a whole lot of questions. I wish I could. That'd be great. But if you have any questions on this lesson, please email me and I will get back to you very shortly. All right, so there's your section for developing, and you'll see problems like that on this section. So hopefully you'll see you around.